Alright, this is JDCNC, and I just wanted to have a introduction for the MIDI file stuff. So if we do a file import, we always do an import of a MIDI file, not an open. Pinkster.mid, for example, open, and it creates a MIDI object here, and it renders that object with the notes and the MIDI note numbers here, and where it needs a note played it'll just do a circle, and if it has a note down repeats and a note up later on, it'll generate a series of circles, and there's all sorts of parameters to measure those. We've got the if there's more than one track within the MIDI file, it'll paste them, you know, one here, one starting here, etc. And the distance between track 50 millimeters. Distance between notes vertically. Paper speed in millimeters per second, because the MIDI file, of course, it's all based in timing, in seconds, and so if we set the paper speed, that effectively gives it the scale in the x-axis. And the note diameter is the diameter of the holes of these circles that you would cut through. And the distance between held notes is stored as a formula rather than as an absolute value. And where we have a property called note space diameter, then we can't have the space for a single value, so we use note underbar diameter plus and 0.25 millimeters. So whatever the diameter is, and it will leave quarter of a millimeter between the two subsequent circles. Now that might be only approximate, in that we want them evenly spaced, and of course this formula may not give an exact number. So what it does is it works out the point for the first hole, point for the second hole, and it divides it evenly so that it's as close as possible to that distance there. Now, well, I suppose the other thing I should mention, I'm moving the mouse wheel, and depending on where I move it, it'll zoom in or out. But it'll zoom in or out around where the mouse is. So if you want to zoom up around, you've got to move the mouse around and scroll the wheel, and that's how you get it to sort of zoom into where you want it to be. Now we can say filter notes by scale. Here you go. If I turn that off, and it takes a moment to redraw. There you go. So the lines, or the notes marked in red, do not exist in the chosen scale. We've got a scale with a name of 31 note scale G to C, and the scale numbers include the list of note numbers that are included in this scale name. And so if there's a note within the MIDI file itself that does not exist in that list of numbers here in the scale numbers, then it will be drawn in red and omitted from the result. And you can, if you don't want to take up the vertical space with those, then you can click this filter notes by scale option, and you know, and it'll shrink it down. So you're only seeing the notes that are in the MIDI file that are also in those scale numbers list here. Now, and in fact, you could even do a file save as. I'll bring this over here, and you can save it as and you can choose the musical instrument digital interface files MIDI file untitled.mid and hit save, and I'll replace that one. And what that does is it saves the MIDI file, but it omits the notes that are not in that scale. So it only saves the notes that are in the MIDI file and in this scale. And the idea with that is that you can you can hear what it sounds like. If I say play with Windows Media Player, oh yeah, it's not going to say the file anyway, but the idea is you can play that MIDI file and you can hear what it sounds like, and you say, well, if it's on that scale and it's missed those notes, well, it's not going to sound very good anymore, and so there's no point in machining out that part of this thing. Now, I suppose the other thing to note is if I select the object, either select it here in the graphics window or here in the objects list, then you end up with the properties of the chosen object, and of course this is where you can change things. The object title Pinkster comes from the file name when you imported it. Object type MIDI is just a constant. I think I've explained all of the others, position, etc. But what you can do is, while you've got that highlighted, you can go to the machining tab and say add a new drilling operation, and it will generate a drilling object, and with a child of that drilling object being the MIDI object itself. And so in that scenario, the drilling object will ask the MIDI object, please give me your point locations, and of course it will return the centers of all of these circles as drilling locations. And we can set the tool, choose the tool, 3mm drill bit, say, or whatever you like, and we can generate. Let's just save that file. And we can generate the G-code for that. The touch-off point. I'll explain that in a second. And it will generate the G-code for drilling this MIDI file. We'll just give it a bit. It's still working. Now the other change when you are drilling operation with a MIDI object as a child is that we'll change the way the point locations are sorted. Normally with the drilling operation it'll sort just by distance, so it'll go from the first point it finds to the next nearest point to the next nearest point, etc. But that's probably no good if we're trying to punch a long paper tape roll. We don't want to be rolling the paper tape left and right too much. So it'll start from the leftmost end, do all of that, all of the values for that X value, and then move to the next X value, and so on. You'll see in a minute once it's generated the graphics for all of this. I must confess it's taking a little while on this machine now, but anyway, you'll get the idea. And once it has done it, there you go. It generates this Python program, and you can see in the Python program here, and then it executes the Python program to produce the G-code, and you'll see the G-code in this output window here. There you go. And this G-code is drawn, it's rendered, it's re-read in, and it's rendered on the screen as red lines representing the rapid movements, and green lines representing the feed movements. So you can see that it'll drill all of these holes, and then it'll move on to here and drill those, etc. You can see the path of the thing's moving. So that's the order of it. Let's view top again. Yeah, I must have. Oh, there you go. So it's quite a long piece. Let me zoom in here so I can see. Here we go. View top. Oh, it really is slow, isn't it? Anyway, get the idea. So what else could we talk about? You can turn things on and off. Drilling operation. Look, perhaps that's enough of an introduction just for the first introduction.